It is still my pleasure to introduce Dr. Jonathan Middleton, who is a composer, music researcher, and a music professor at Eastern Washington University. The foundation of his work is derived from the web-based software he designed to transform data into musical sounds and expressions. Dr. Middleton's work is often collaborative, with partnerships in the areas of biochemistry, agricultural economics, and environmental science. His latest research involves a multi-year study in data to music with the Human-Computer Interaction Unit at Tampere University and 5 Finnish companies. I'm very curious to hear about this topic myself, and also hear more details about data to music sonification and user engagement, and what's new from Dr. Middleton about adding a new dimension to data analysis with music. Welcome, Dr. Middleton.
Thank you. It's a pleasure to be here. I'll try to stay close to the mic and be able to see my slides as well. So the presentation today is data to music and user engagement, adding a new dimension to data analysis with music. I might be the only composer artist in the room, but that's okay. I collaborate with scientists and I understand their needs. This is my recent article I published with my research team from Tampere University in Finland. It's you can check it out at Frontiers in Big Data. It was published in August, and it was a big step for us. We probably spent 5 years working on this project, which I will explain through this presentation. A little ironic point is that in Finland there is no word for engagement, so it was kind of fun to work with people who didn't even have that in their language. Because we're all new to each other here, I just want to let you know that I'm a classically trained musician, studied guitar, piano, and voice, and sang in a choir as an undergrad. Got my doctorate at Columbia University, and I've been teaching at Eastern Washington University for close to 25 years. And I've studied with many gifted composers, which is a real privilege. And at some point around 2004, I started looking at algorithms and how you can translate numbers and genetic code into melodic lines. And from that point, I started making connections with scientists who wanted to hear their data. I found that scientists were just as happy to see their data or interact with their data as I was to interact with my musical pitches. Normally what I do is teach music composition, and these are my students performing their music at a local radio station in Spokane, Washington. But my professional activities are not just in the creative area of composition, but also in transforming data. And I started with music algorithms software, which I designed and had students develop with me over many iterations, and the latest one you can see is the bigger one on the right. And you have access to that too. It's freeware on the web. You can translate numbers and genetic code if you like. In 2016, quite a few media outlets picked up on my work I did with protein structures, and that actually was a nice stepping stone to the newer work I ended up doing in Finland. We were looking at 3 proteins and how you could hear their structures with musical sounds. So here we're going to be adding new dimension to data analysis with musical traits. Is this possible? This is really, really new research. There's a whole community that is looking at this, but they're not always looking at musical sounds or looking at any sounds. And a very simple example might be a Geiger counter, whereby the closer you get to radioactive material, the more intense the clicks, or more speedy and intense the clicks are, indicating danger, whereas otherwise you just see it on a meter. and that intensity gives us some sense of urgency. But that isn't particularly musical, although it depends how you define music. But that's the most simplest example of something that's been tested and been around for a while. So I'm just going to propose to imagine your data as a table. And I know many people are excited by tables, but I can think of that maybe as one dimension. And then imagine your data plotted on a graph with lines and colors, and you might perceive of that as adding more dimensions. It's giving you more information. So here we have, with standard tools, the means to graph what was on the table. And this is actually the heart rate data of a trail runner. And you can see that this person was running for over an hour with their heart rate beating at 150 beats per minute, which is pretty intense run. And this software interface that you're looking at is the software we developed in Finland. It's now in storage. I have to go unstore it, hopefully in August next year when I plan to go back. But right now it's not entirely accessible, so I apologize that I don't have that for you, but I do have the other website called Music Algorithms that you could try if you want to. So we see the graph line, we see the colors, we know a little bit about the data, and the question is, what does this sound like? Or what could it sound like? Or maybe what should it sound like? And we have to imagine how data has a function, but what about its form? So what I'm really proposing is to think more about the form and the design of the way we interact with our data. A simple example is which Pluto conveys the most information. This is a standard slide I've used a lot. It's really heartening to present it here in this building, since there's some astronomers maybe in the mix. But the Pluto on the upper left is probably the most authentic, but the ones below and to the right are colored. And I assume those colors convey some information. And then so that we're diving into perception. Somehow we seem to know what the colors mean without having a user's manual. If we look at Hurricane Irma on the right, what are the most intense areas of the storm? Probably the red. And in the polar vortex that we've had a few now, this is from 2019, I think, that came down through the Midwest, the reddish pink is the coldest region. So now to the fun stuff. Let's hear that heart rate, and below you can see a MIDI file, which I'll play in a minute. And you can kind of see the contour. I don't know if I have a mouse. Yes, I do have a mouse. You can I try to line these up as best I could, but you can kind of see some dips here in the data where the heart rate went down. And you can see the dips in the musical line that track with it. This has a scroll. It will scroll for a bit, and you should be able to follow pretty well. But towards the end, the file actually, the MIDI file sort of moves, so just be assured that the data above matches what you hear below. So this is the point where you're really, really impressed or wondering what's going on. My friend is a doctor who actually teaches at the UW Medical School, the branch that's in Spokane, suggested maybe I should use percussion. and heartbeats and percussion make a lot of sense, but I want to do something a little different. So hopefully you could hear the melody go higher as the heart rate went up and the melody go lower as the heart rate went down. What this didn't demonstrate was the intensity of the run. So that's something I did not capture. I captured something really simple that we can all track. I could actually divert my eyes, look away, and sort of hear the low notes and kind of read the data that way orally. But there's also, the intensity of the run. And if there's time at the end, I'll play a version of this where the intensity is present. But for now, it's just kind of like a proof of concept. I do like to use paper and old school stuff, so I pasted, you can see the flat line at the top. That's barometric pressure, and it looks pretty dull and unmoving. But when I put it through an algorithm to hear how it would sound, I was surprised to see there's actually the scaling that I used created a really nice ascending line of musical notes, which you can track from over here, if you can see my cursor up there. Yes. And then going up here. And so you can hear from the graph, you can't see much, but from the sonification, you can hear the barometric pressure rise. And my understanding with that is that's good news for the weather. You'll get sunshine, something we all like to see in Washington State. So let's hear that. And this is just the barometric pressure sonification. Sorry, I didn't have the whole scroll thing going, but you can take my word for it. The music is accurate there. Now you might ask, okay, this is fun and nice. We got a data set and we can hear it, but what if you merge multivariate scenarios where you have more than one data source? And I did add sunshine data to this, and we will hear the sunshine data, but unfortunately, it's so bright and present, it kind of masks the low end of our musical line. So it's going to be hard to hear the barometric pressure with the sunshine. And actually need to take the volume down just a little bit. But let's see if you can hear the barometric pressure poke through. And it's supposed to be bright to indicate that there's sun coming out from the clouds. And this is the brightest area. So that's me working with weather data, which was a part of the 5 companies I was working with. I only think this could happen in Finland. There were 5 companies that wanted to hear their data for various reasons. And when I first spoke with the company folks, I said, you just want data with sound. And they said, no, we want data with music, because in Finland, design matters a lot and user engagement matters a lot. So I was just charmed to no end that I get to work with music and data with them for 3 full years. Yes?
Sorry, what determines, I might have missed this, what determines the timbre? Because it looks like it's going from like 4 notes to 1 notes, or am I...
Yeah, so I will dive into a little bit of music without getting too technical, but what we see above are standard quarter beats. So you get a standard beat, and then later on it gets a little faster with 8th notes, is what you're referring to. I don't remember exactly how I mapped the rhythm, but there's definitely more activity going on the higher we get. So it could be just that the higher the numbers are, the more rhythmic activity is added, just to add more energy. But in this particular algorithm, I actually had some randomness built in. And that may seem a little scary to you all, like, what do you mean you're adding randomness to me perceiving my data? But the slight degree of randomness, which I actually, if you're familiar with Markov chains, I used a Markov chain model where I just, 20% of the time we're going to add a little decorative thing. And that makes it a lot more musical and a lot more, well, hopefully more engaging. You might be familiar with sonification, or maybe not, but you can see there are a lot of fields that link to this. This is actually from a renowned book you can get access to called the Sonification Handbook from 2011. And my world for probably a decade or more has been data, computer science, and music. And then now with what's going on in Finland, I've added some more areas to this, which is exciting. And that's kind of shows through in the Frontiers publication. Any questions so far? Your question came a bit early, so any other questions so far? Yeah.
I'm curious if you've looked at, and perhaps this is not getting into, perhaps it doesn't make sense with the data sets that you have, but as, let's say, like the barometric pressure is going up, right, new notes are going up, have you thought about representing, I guess, your music as like the derivative of the data? So rather than looking at the absolute value of the barometric pressure go up, the music represents like the rate of change at which the...
Yes. So in other words, do I have to be so literal or can I be more general about it? And I'm repeating your questions as well, just for the audio as well, so don't. One of the companies, and again, if there's time, I'll share that with you. One of the companies didn't even want, a direct correlation between the numbers and the music. They wanted a song. And so the company, they make smart watches for athletes, and so they had all kinds of data from people's outdoor routines, and they wanted their clients or their customers to actually go home and download the data from their watch, and then to have a song done. And that's pretty tricky, but we managed to make some really nice prototypes for that. And what we ended up doing was, music has a lot of repetition in it to be convincing, at least in the popular world. So we ended up looping a lot of the data, and I developed something called the cascade model, where we took one segment of the data and presented that, and then repeated it, and then added another segment of the data. So let's say it's heart rate, we repeat 3 times, and in the first repeat, you would have some other data set like altitude. Maybe it was a runner going up a hill, cadence, speed. There are all kinds of other data sets. So that looping wasn't very faithful to the data, but boy, it was convincing to get some really nice, a visceral understanding of what was going on. Any other questions? Yeah.
So there's like 12 notes in music, like at least in like standardized format, like more blues. So when you're assigning like data points to notes, there's like, at least in my head, there's like a natural concern about key signature messing up or dissonance occurring. Does the program or algorithm manually adjust like any potential dissonance or like weird things that occur in the melody in order to make it more pleasing, even though it's a little bit less faithful to the data?
Yes, and we call it listener friendliness. You can map it to major, minor keys and make it more accessible. Or you could leave it, let the chips fall where they will, and have those dissonant tensions, which actually could tell you something important in your data set. So you can go either way. You'll see some of the interface in a second. I'll hold that thought, and you'll see more in a second. So we call the D2M for Data to Music project, and working with 5 companies. And again, each company had sort of different objectives. Some just wanted notifications and alerts. So in fact, I could use a threshold system where most of the time we didn't hear any music, and then when the data exceeded a certain threshold, something would play. The thresholds could be low end and high end. Others wanted a song, and others just wanted to convey information for their staff or customers. Schneider Electric was one company. Sunto was another. You may have heard of these companies. Trying to think, there's another one I think that's more multinational, but I'll just move on. So what we thought we'd do is just build the software for this, and I didn't come to it from scratch. I had a little over a decade of working with mapping systems, and then transforming these into sonifications to serve their needs. And of course, to serve my team's needs, we needed to do some validation effort to publish what we're doing. And so the obvious question for me was, are the sonifications of data for the 5 companies perceived with some accuracy? And although this is the question I would want to answer, I didn't really have a foundation to build this on because there aren't enough researchers working with music and sonification. That's a really, a lot of people feel like music, that's art, separate that from the sciences. It's a little bit risky. People have different tastes. There's a lot of kind of hands-off stance with that. So a far more fundamental question for the auditory display community called ICAD was, why use musical sounds, or why use musical characteristics for sonifications? And which of those musical characteristics are the most effective? I won't dwell on this too long because I don't think you could go read the paper if you want the details, but I did have 72 participants with listening tasks. There were 3 conditions: pitch, timbre, and rhythm, in the context of melody, chords, and rhythm. And there were 31 questions which came to the participants as statements. Like, I felt X, Y, Z, and then on a Likert scale, they would click a number. And there are actually 6 factors of engagement, according to O'Brien and Toms. Heather O'Brien works in UBC, up north from here. And so these are the factors of engagement: focused attention, perceived usability, aesthetics. I'll give you a hint. Music did really well with aesthetics. Durability, novelty, and felt involved. And O'Brien is now consolidating the last 3 into something called reward. I'm not so convinced yet that that should be done. And by the time she came up with the reward idea, I'd already started my survey, so I have to apologize that I just wasn't going fast enough for her. These are the results from the melody survey. There were 3 surveys: melody, chords, and rhythm. And you can see some of the results of the different, where am I here? The different conditions, pitch, timbre, and rhythm. Sorry, I shouldn't have done that. Hurry up. And so I got 93 survey results from as you can see from the graph. You can see below the factors of engagement. And then these are what I call questions that they're responding to. And the questions kind of line up with the factors of engagement. So there are quite a few for focused attention. And I lost my mouse. There it is. And there's a few for aesthetics, very few for novelty. I thought I would do really well with novelty, but not so well. So the 31 questions times 3 conditions times 3 studies, 279 results. And thank you for the statistical significant differences, yielding only 14 results to report. And what did that look like? Rhythm is complicated and really worked the best for us when it was very simplified, and it it scored a point with focused attention. We will have an example of that in a minute. Perceived usability only got one factor there for that, and it came with melody with pitch, timbre, and rhythm. You'll understand what I mean by pitch, timbre, and rhythm in a minute. But got a lot of results with aesthetics. That scored really well, and you can see from the median values, it was out of 5, 1 through 5, that there was quite a bit of engagement. At least they felt so. Very little with novelty, and only a few examples where chords poked through in the results. So melody with pitch and timbre actually did really well. So in summary, moving forward, I need to think really carefully about how I use rhythm, because it can confuse people. And I can rely on aesthetics to engage users. And timbre, which is the quality of a sound, it's the character of a sound, it's the harmonic spectrum that we hear along with some noise. That really matters a lot. That does a lot to engage people. And in terms of novelty and perceived usability, I only had marginal results, and chords as well. So a lot more work needs to be done in those areas. And there are actually some factors that I didn't get any results from, like endurability. I think I'll move forward for the sake of time and take more questions later. This is a survey flow. I'll just breeze through this. It was randomized in 2 different ways. But every time users answered the questionnaire of 31 questions, they actually had to do some tasks. Each session took about 30 minutes. These are some of the questions or statements they were responding to. I lost myself in the sound experience. This is all related to focused attention. Notice one statement that has a lot to do with engagement is I felt frustrated while listening to these tasks. That being frustrated can actually be a part of engagement. This is what the interface looked like with the testing. So we'd basically play some music or data with musical characteristics, and they would click every time they heard clouds or sunshine or wind. And all of those results, all those little clouds that puffed up, we didn't count that. That had nothing, we didn't register it, it wasn't recorded. What mattered was the survey statements of how they felt when they did this. Next time I do it, I will track how accurate they are. I think we're going to hear something at this point. It's a little boring at the end because the data is boring. You could hear dum, dum, dum endlessly, but sometimes you could hear a little lick or a little riff. That's the algorithm putting in randomness. So there's always a little bit of extra something. Those are octaves. I think it's a scale of 0 to 6, if I'm correct. Have you heard of octaves before? OKTAS. It's cloud cover data. And basically, I took the cloud cover data, and you see as the data go higher, and numerically you get more clouds. But for me, that creates higher pitches. And I thought, clouds are heavier to me, they're darker to me. So I inverted the graph, I inverted the data. And again, if you want to hear your data, you need to be a little bit bold with it and be ready to invert it. So you can hear how, if I can find my cursor, this line begins high, which is representing sunshine in my head, And as it dips low, it gets a little darker, which is the clouds. And you can see how boring it is at the end. It's just the same. I think this is in Finland, by the way, so I guess it was a day they only had a little bit of clouds. And this is what the music looks like with chords. This is kind of what you heard. And we can play it again. You see the dip? If you have any musical training, you might hear the lower sounds and towards the beginning, and that's where the clouds came in. This is not precise, it's just a general score. And the score is shorter because I compressed the number of data points I was pulling when I made the score. So instead of doing all the data points, I did some of the data points, which ties into an earlier question. Could you kind of like, be a little less faithful to the... Another thing that I did was, you can see this is the interface for the software, and you can see I have a slider for the rhythm, simple to complex, and it's at level 2. So I could, I'm not really saying I want exactly this rhythm at this time. I'm saying I want a collection of rhythms that are more active or less active, more complex or less complex. And notice how I did invert the graph in the middle to get the sunshine and clouds feel. But at the bottom, for rhythm, I actually wanted the rhythm to intensify as the clouds come in. So I kept the graph as it originally was. So I'm looking at both pitch and rhythm in different streams of data influencing them. And this is what it looks like when it's just a melody. I apologize for those who don't read music, but you can see the dip here that you saw before. And you can see how boring the rest is probably going to be. And this will torment you a little bit because this is the example I'm presenting to you with pitch without timbre. So when I said the contexts were pitch, timbre, and rhythm, this is what people heard without timbre. What you have to imagine, it's kind of colorless pitch without any color. It's sine waves. Here we go. Hopefully you'll be patient with it. Oops. And this did not score very well with aesthetics. Yep. I'm going to move on. One of my friends said, you really should share what rhythm is because not everyone knows, everyone has a sense of what rhythm is, but maybe the definition. So it's basically varied durations of sound of different length. This is from the wind data. And again, I didn't get a lot of results from the wind part of the survey, and I probably need to look at that more carefully in the future, but this will give you a sense of what wind can sound like. So listen for more rhythmic activity, suggesting more wind in the data, and less activity with less wind. Hope that helped. And this actually tied in. This was the example that actually helped score a point with focused attention. I don't know. Did you feel like your attention was focused? Maybe. Okay. So if you're interested in this, I'd be happy to receive emails from you and give you any kind of advice you're looking for. If you go to the Frontiers article, all of the May, I worked with 3 months, April, May, and November. This is from Finland. And you can actually hear all the May files. You have to download them on a zip. Or you can go to the Mendeley site. There's a link for my Mendeley, which has all of the survey data and all the files. And yeah, that's what the link on the right in blue is showing, leading to the Mendeley site at the bottom right. And so the next steps now for me is to see if I can collaborate with more scientists. There's only one company left for me to work with in Finland at this point, but I think I'd rather work with scientists now and see if I can validate the accuracy of the sonifications. So there'll be a win-win both for me and the scientists that I work with. And my colleague from the business school at EWU is willing in spring to start developing a parametric scale model for with ANOVA regression, terms that are not entirely clear to me as a trained musician, but I have faith in him that maybe we can get better results to report with maybe a more refined statistical analysis. And that would be the what I do in the spring. And then I may have to go to Finland for August and September next year, but definitely looking forward to see if I can collaborate with more people. And I don't want to keep the volume up too high. Oh, questions? I think I'm done. Thank you. Yes? I'm trying to, if I can understand your question correctly, I use discrete data. Maybe why did I do that? And I'm just trying to make things as simple as I can at this stage early on in the research, because it's hard to find people doing this kind of work, and just trying to simplify the concepts. Yes. Yeah.
I feel like this may have come up at some point in your thinking about encoding data, but have you ever considered how you would go about encoding spatial data into music, or adding more dimensionality to understanding what's going on?
So are you referring to the data being more of that nature rather than the result? Because you could I have a former student of mine who actually uses spatial results from the musical sounds in a spatial environment. And we actually worked on salmon migrations, worked with a scientist at the University of Idaho, and it was very spatial. But I have not worked with data that's spatial, and would look forward to collaborating. Again, that's not my area of expertise, so I'm treading very carefully unless I work with someone who's got that need. I worked with a protein structure specialist, and it was amazing to see his look on his face when he felt like he was inside the structure, and I didn't have the same feeling. I didn't know. It was great to see that he felt great. So it really depends on who I'm working with. Yes, over here.
Kind of a follow-on from that, not necessarily about spatial data, but about non-time series data. So all the data that you showed here was consecutive measurements in time.
I'm not sure. So this has to do with the. I'm working with time series, and how would I approach it with non-time series? Do you want to give me an example of what would be non-time?
Yeah, you could imagine taking like a thousand measurements of like each gene expression at like a single point in time.
Mm-hmm.
Like how it's yeah, it's like hard to see how you would translate time series data into time series data, but that could be quite cool.
Yeah. So it also depends on the collaborator that I'm working with, what their needs are and what they're looking for, because I'm presenting some very simple examples to convey a concept, but I've had all kinds of different people I've worked with different needs, and so it really just depends on. Don't assume that there's a generic algorithm for everything. It's really the first thing I ask collaborators. Okay, explain the data to me, and what are you trying to hear? And then we build the algorithm or set the parameters, set the settings for the algorithm to meet those needs. As I said before, one simple example is setting thresholds where you don't hear anything until something crosses a threshold, and then maybe compressing, taking only a few data points rather than, it's really hard to hear the data for something that's lasted a year. So you got to okay, what time intervals can you work with and things like that. Any other questions? Yes, with the hat.
I guess two questions. A follow-up to that last question. Thinking back to the barometric pressure data, there was like variation in the rhythm,
Mm-hmm.
and like straight like quarter notes, and like 4/4. Like how was complexity or like the implementation of like random eighth notes just because like of that slider that you showed earlier to add complexity, or was there like another data set to help like decide it?
No, the algorithm used like a Markov chain, and I could set the slider to complex or simple, and the more complexity I added to the rhythms, and that I could add complexity to chords as well, is just based on, do I want more activity, more intensity, or less? And I have no direct control over that. The algorithm will generate a different result each time, but a similar result. I could trust it. And I was okay to let go that way so that I could have a more musical, real experience that's more musical. And we can all appreciate how jazz works with, lots of rules for sure, but a lot of improvisation, a lot of spontaneity. So I was trying to capture that spontaneity. You had two questions, and there was a hand over here.
Yeah, I mean, the last question was like kind of answered from your last answer, but like the implementation of chords in the music, given the data is like a discretized data point, like the choice to add chords was already implemented in the algorithm to add complexity.
So the programmer I worked with, who sadly passed away a year and a half ago, he saw these as streams. So each data, you have your data sets, and you could choose which one you want to work with, and you could make various streams with even a single data set. So you could manipulate the pitch, manipulate the rhythms, manipulate the attack, the way the pitches are approached. And so we could have like 5 streams for a single data set. And so we had lots of flexibility. It was really, really nice. Yeah.
When the data is harmonized, or I guess when the algorithm harmonizes it, is it biased towards any types of chord progressions, or was it just non-functional?
Yeah, I was very careful not to use the word harmony. And I'm glad you brought up harmonize. No, it's just chords, and there's no syntactical language applied. It's just the chords are there. And I can't remember the details of how. I know chords are built vertically. Everyone has to imagine, and they can be dissonant, or they can be pleasant or unpleasant. And so I think I played with the pleasantness and unpleasantness. I'm trying to speak in very general terms. Yes?
I seems like you're mostly using like pitch as the encoding of the data and the other factors as kind of preserving kind of a musical like rhythm and stuff. Is that fair to say, or?
I tried to be fair to all the other musical characteristics I could, but I found through the survey results that pitch really does play a huge role, in particular pitch with timbre. And I was really struck at how important timbre is, the color of the pitch really, and you saw how boring the pure tone version was. But I tried to give rhythm a really good shot, and I actually had like a drum set rendition of Wind, and which I loved and I thought was so convincing. I mean, there's nothing as engaging as seeing a drummer go crazy on the drums, right? It's just really exciting. There's so much energy there, but the survey just flopped. The listeners had no idea what was going on. They were lost, and they felt frustrated. So I have to look at that more carefully, see what's going on. But yes, a lot of people gravitate towards pitch. That is a good starting point. But how they use it, like I was inverting it to get the deep, dark clouds. I was not faithful to the data. I was trying to evoke a musical expression that I thought matched people's impressions. Yes?
Did you, in all of this work, do you spend time with doing like listener pre-training before they kind of experience the, for instance, it's like when we look at a graph, we have the axes and we have to understand what the axes are and
Yeah.
what the directions mean and in colors, what that means.
Yeah, a little bit of training would be great. I had a student come up to me. I did this presentation at EW, and one student came up to me and said, "You need a key. You need like a sound key that people, what to look for and what to listen for." So I think that's a great advice, but maybe that's the next step. But I wanted to throw these poor human subjects into the deep end and see what I could start with. By the way, I've had some other files where I was playing music that sounded cold to me, and as the temperature was rising, the melody was falling, because as the melody goes down, it was getting warmer in my sense. But I've had so many mixed results with people saying, "Oh, I can hear I hear the melody going up, the temperature's rising," but that's not what my hope was. So I've gotten it wrong quite a few times, which is okay. That's how we learn. Yes? A little bit. I'm trying to do this for everybody, and I like to help everybody. Is kind of where my point is at this point. The question is, does my work can it help people with disabilities, or have I thought about that? And I have thought about it, and I've had a lot of people say, "Oh, yeah, this would be great." But I want to be more broad for now because that would be a big step or a new direction for me. Any more questions? Do you want to hear the runner song that shows the intensity of their run? So it's not at all faithful to the data, but it's faithful to the impression the data gives. Do I have time? Yeah. I'm going to keep the volume down a little bit. It's very popish. Oh, wait, there's more here. Yep, that's it. This has altitude, cadence, heart rate, speed, vertical speed. Should I still play it? Sure. Okay. Is it okay? I'll just play an excerpt. This is all algorithmic. There's nothing controls. there for us because I know we ran out of time. So thank you.